Since India's independence in 1947, the country's energy infrastructure has evolved from producing a measly 1350 megawatts to churning over 200,000 megawatts. Despite the incredible advancement, India is still facing an energy crisis. About 70% of India's energy generation capacity is from fossil fuels, with coal accounting for around 57% of India's total energy consumption. More than 300 million Indians still have no access to electricity. Most of them reside in rural India. With a growing economy and a 1.24 billion population aspiring for a better quality of life, India's energy demand growth is inevitable. Coal mining alone in central India threatens over 1.1 million hectares of forest land and tribes dependent on forests for their livelihood. These forests are inhabited by endangered animal species. India is the fourth largest carbon dioxide emitter in the world. This is due to increased coal consumption, which represents 67% of the increased emissions. In contrast, renewable energy does not pollute the environment or produce greenhouse gases. It is the appropriate solution to climate change. But as a country, we continue to lag behind in our intention or action on using and promoting renewable energy. Only 12.25% of India's energy generation capacity is from renewable energy resources. With its natural resources, India can emerge as a renewable energy superpower in the world. Only a fraction of the total potential of renewable energy sources has been utilized in India. Gujarat government has taken an unprecedented initiative to promote renewable energy projects like the Canal Solar Power Project, in which 18,000-kilometer-long network of Narmada canals across the state is intended to be used for setting solar panels and generating electricity. Another initiative in Gujarat is the Charanka Solar Park, where groups of thin-film photovoltaic power systems are being set up on a 2,000-hectare site in the district of Patan. Solar power has produced electricity in every diverse region of India, from rural Bihar to mountain terrains of Ladakh, from villages of Rajasthan to a metropolitan city like Bengaluru. In Bihar, farmers have used solar energy to generate underground water for farming and fish culture. Ladakh, which is a very high plateau in the Himalayan range, experiences heavy snowfall and remains cut off by road from the rest of the country for several months in the year. There, solar energy is used for cooking, lighting, and heating.
We first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the two types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the n side, while the hole is drawn to the p side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades.